Hello and welcome to this video. The purpose of this video is to kind of give an overview of the qualitative analysis of the group 3 cations. The majority of the substances in this group are in the transition metals. And so we're going to walk through kind of what this group holds, what some of the procedures are, and then finally how to interpret the results and look at the pre-lab assignment for this experiment. So where we need to start with this is we need to look at what is it that we are actually investigating here. And so what we're looking at here as far as the group 3 analysis is concerned is the majority of these are transition metals. We've got iron ions, we've got cobalt, nickel, manganese, aluminum, chromium, and zinc. Now, what sets these apart is that we have substances here that are insoluble in bases or insoluble in bases mixed with ammonium sulfide. And so the reason for the distinction here is we will take this solution and we will blast it with ammonia. And that ammonia in the form of ammonium hydroxide is going to create a series of hydroxide salts. But some of these here, in particular zinc and a couple of the others, actually complex in the presence of ammonia. And so what we're going to do with those instead is, instead of just letting them float out there into something else, we're going to hit them with ammonium sulfide and turn them all into sulfides. So like zinc sulfide, CNS in that case. Same thing for the nickel, same thing for a couple of the others. So if we're looking at our flow chart here, we can see that that's what this first step is all about. Some of the compounds are going to form hydroxides. Some of them are going to form complexes, cobalt, nickel, and zinc. And then manganese is actually going to do neither. But when we hit this basic solution with ammonium sulfide, the cobalt, the zinc, the manganese, all of these guys are going to turn into solids. And so it'll be this combination of solids that we take with us to the next step. And then that next step is after we have separated. So after this step, we would throw out the decantate. And move forward from there. So decantate gets thrown out. Now we hit the remainder with nitric acid. The nitric acid gets all of these compounds because it is a strong acid. And we're actually going to use agua regia as part of this as well, to get all of this stuff to redissolve. And so in the process here, we have turned all of the substances into ions again. We're going to hit them again with base and with peroxide just to make sure that we're going to do a couple of things. The peroxide is going to help oxidize the chromium into the chromate. It's going to fix the manganese's state and turn it into manganese 4. It's going to turn the cobalt into cobalt 3. And it's going to make sure that all of the iron turns into iron 3 plus. So we hit it with hydroxide. The hydroxide forces either the complexing in the case of aluminum and the zinc, or the formation of the chromate ion. And these other solids. And so this is where we split into our two subgroups. Over here on this side, we have what is known as the nickel subgroup. And on this side, we have the aluminum subgroup. Each one of these subgroups is going to have a different analysis that takes place. And what we will see is that for the nickel subgroup, we are going to basically treat them all the same. We're going to hit them all with sulfuric acid and peroxide, get them back down to their kind of original states. And we're actually not going to separate them any further because the chemical reactions that we have in place are specific. They are specific to these individual ions. And so we don't need to separate them because there won't be anything that would give us any kind of inconsistency or an unsettling result. So for the iron, we interact it with potassium thiocyanate, or excuse me, yes, potassium thiocyanate, and we form the blood red complex ferric thiocyanate For the cobalt, we're going to do something similar. The cobalt also uses the thiocyanate ion and creates this blue complex. Now, if iron is there, this blood red complex is going to be far darker and kind of obscure this. So sodium fluoride is added to create a different complex, a fluoro complex for the iron. And this complex is colorless, which will leave behind the blue solution here. For the nickel, we're going to just hit it with ammonia to get it to complex. And then we're going to hit it with a substance called DMG, and it's going to form a different complex. This complex giving kind of a strawberry red color. And then finally, for the manganese, we're going to hit it and get it acidic. We're going to treat it with a bismuth compound. That's going to turn the permanganate solution the manganese solution into permanganate. Permanganate, you may recall, is kind of a pink to purple color. And so that's kind of how the nickel subgroup will go. For the other subgroup, we'll see a series of steps as well. The first step will be to decomplex these. So getting the hydroxyl complex to aluminum and zinc. The high concentration of acid will turn the chromate into dichromate. We'll then hit it with ammonia, which again, ammonia also has the form of ammonium hydroxide. That's going to cause the aluminum to precipitate since it does not form an ammonia complex. And so we will do a series of steps to characterize it. We'll add some dye to turn it a reddish color and help us pick it out from other substances. For the other side, the chromate ion, we will treat with barium to make the yellow barium chromate compound. The zinc we will treat with hydrochloric acid and potassium ferrocyanide to create a more complex compound that is kind of on the grayish to grayish blue teal kind of scale. For now, we're going to ignore this step down here. That will only get used if we are absolutely unsure of the presence of the chromium. And the primary reason we're not going to mess with it too much is because the ether is kind of a nasty compound and we don't want to use it unless we absolutely have to. So that's what's going on in this experiment from an experimental standpoint. And if you look at the procedures, you're going to get kind of the same format as what we saw in the group 2 analysis. Each procedure kind of tells you what's going on in each of them, and the individual steps walk you through the process itself. The notebook, very similar to the notebook that you did for group 2. Again, part of your pre-lab is to pre-build those tables and upload them here into the notebook so that you are ready to go day 1 and you're not kind of sitting around waiting. We saw what happens in the group 2 analysis when we are just kind of sitting around waiting. Things go a lot slower than they should. So as far as the pre-lab goes, same kinds of standard questions that we have seen in the other qualitative analyses. What is the purpose? What are the ions? What do we use to separate the ions of this group? And so what we want to make sure that we're aware of here is that this is how we separate it from the rest. So we're talking really here about ammonia buffer and ammonium sulfide as being the things that precipitate out these ions and leave behind the group 4s. For questions 4 and 5, I would invite you to go back to our flow chart here. It's asking about what happens to the chromium ion and the manganese when we put them in the presence of peroxide. And we can see it's in this step here that we're talking about. We can see that the chromium turns into chromate and that the manganese turns into manganese 4 oxide. And so question 5 is in the same kind of tenor. Look at the flow chart here, see what happens when we add the peroxide in the highly acidic solution, what happens to the manganese. Went from manganese 4 to manganese 2. And then for question 6 here, you just need to look at, again, the flow chart. What is the end product? What reagent did we use to get that end product? And is that end product a solution, like a complex, or is it actually a solid material? And then the answer to this last question is not readily apparent. If you go to the discussion questions, they do give you the answer right there. The talking about the aluminum subgroup forming hydroxo complex ions. So that's it for this particular pre-lab video. Thank you for your attention, and I hope that this was helpful, and I'll see you next time in lab.